So a one-step equation would have looked like this. You would have had x plus 2 equals 4. This is a one-step equation because there's only one number attached to the x that needs to be moved to the other side of the equal sign. This plus 2 is being attached to the x. We have to move it to the other side. We move things by doing opposite operations, right? And that's what I preached yesterday all day, was opposite operations. In this case, the opposite of plusing 2 or adding 2 is subtracting 2. And that will move it from the left side to the right side, but you also have to minus 2 from the right side. This would then leave x on the left side equals 2 on the right side. That would be your solution.
I mean, if you just solve, because what else would you?
For sure, man, you could. But then when you get to bigger questions like this one, and I say, okay, what does k equal? Like, if I said, okay, what value of k works here? You're not going to look at that, no. So if you just decided yesterday, no, it's not 7 either. That's what I mean. So it is 2, yeah. So these questions are going to get too hard for you to look at and understand. It's just a matter of fact. Tomorrow is getting bigger and harder too. So you're not going to be able, it's not going to be able to work out. You have to do opposite operations. You don't got a choice. So yesterday was one-step operations. Today, it's going to be two-step operations. Tomorrow, it's going to be like 3 or 4-step operations. It's just going to keep building, and the equations are going to get bigger and longer. So if we look at this first one, if we want to solve for m on this, the goal is to get m by itself. There's 2 things I have to move. I have to move this 4, and I have to move this 3. And you have to move them in the right order. So you have to know which one to move first and which one to move second. The way you decide is you're going to move additions and subtractions first, move multiplications and divisions second. So in this case, I need to move the plus 3 first. And you do it by doing opposite operations. So this is plus 3. The opposite of plus 3 would be minus 3. So I'm going to subtract 3 from both sides. That will move this 3 off the left side of the equal sign so that you only have 4m, and on the right side you have 8. You move additions and subtractions first. Then you're going to move any multiplications or divisions. This means 4 times m. Right? Like there's no symbol there, so it means multiplication. The opposite of multiplication is? Division. So we're going to divide both sides. Yeah, Jordan. Yep. 8 divided by 4 because you got to do it to both sides. You're now left with only m on the left and 2 on the right. So the answer to that question would be m equals 2. I know some of these you can do in your head. I get it. And so it's hard to just not do it in your head. But I also know how challenging these questions are getting. And if they're too hard for me to do in my head, they're probably going to be too hard for you to do in your head. So learn how to do opposite operations, and it'll work every time. If we look at B, there's 2 numbers I have to move. I have to move this 2 to the left side or to the right side of the equal sign, and I have to move this minus 14 to the right side of the equal sign. You need to move the minus 14 first. The opposite of subtract 14 would be, yeah, so you add 14 to both sides. You get 2x equals 6. Because those 14s will cancel out. You then have to move the 2. That's 2 times x. The opposite of timesing is, so you divide both sides by 2 to move the 2 to the other side, giving you a final answer of x equals 3. Right? Opposite operations. If you move the right thing first, then you should be good. If we look at C, the first thing you have to move is that plus 6. The opposite of adding 6 is subtracting 6. So you subtract 6 from both sides. That leaves you with 3a equals negative 30. Now that I've moved the 6, I need to move the 3. You move the 3 by doing divide by 3 to get
That'd be minus 10.
a equals negative 10. You got it. Truly, it's not going to be that hard if you just get the process down. Yeah. But you've got to learn the steps, and then it's the same steps repeated over and over again. If we go up here to D. Actually, you try D, E, and F on your own. If you look at that D, the first thing you have to move is you need to move that 6 over, right? So you add 6 to both sides, which gives you 24 equals negative 4k. At that moment, I think most of you got there, and then you get stuck in this, like, I got to divide that k over, because that is timesing, right? That's negative 4 times k. So when you divide, you are dividing by negative 4, not by positive 4. That would give you negative 6 equals k. So check your answer, see if you got it right. Did you get it?
Yeah, I got 6 equals negative k.
Ah.
And then I got negative 6.
Yep, that makes sense. So if you ever end up in that situation,
I just didn't put the negatives where the full was.
Yeah. Like if you get that, you can just flip the negative over. Just like move it. It just becomes negative 6 equals k. Yeah. Awesome. C. We've got some decimals in there, so it's going to be a little bit more messy. You still want to do opposite operations, and you still want to move the subtractions first. So this is a subtract 0.8. Boys. The opposite of subtract 0.8 is add 0.8. That'll leave you with 2a equals 2.2. You then need to move that 2 to the other side. The opposite of timesing is dividing. So we divide both sides by 2 to get a equals 1.1. Cool. The last one. Check, see if you got it right. So the last one, we've got that plus 0.23. That has to move first. So we are going to subtract 0.23 to both sides, which is a nasty number. Negative 0.05. Is that what you guys got? Perfect. Then you need to move that 0.4 to the other side. The opposite of timesing is dividing, so you're dividing by 0.4. I don't know what that's going to equal. 2.5? Yeah. Weird number. And that should have been your answer. With those decimals, like, make sure you're using your calculators. And like, those are too hard to be doing in your head consistently and doing them properly. Again, I always kind of go by the rule of thumb. It's like, I'm pretty good at math, and if I'm not doing it in my head confidently, I would definitely use a calculator. Which spot alert? F?
Hang on, I think I put it in.
Okay. Cool.
Oh, I did. Okay.
We're going to look at these ones where it's going to start to get a little bit trickier. The reason it's trickier is there's a lot of things now. So before you start solving and before you start moving things, we're going to do something called collecting like terms. So if you look at this question, you're going to notice that you have two n's in the question now. You have 6n and you have negative 9n. In math, that's called like terms. I like to imagine n is something. I almost always go with food because I like food. So I imagine this as you have 6 cookies and negative 9 cookies. You can combine those things together to say how many you have overall. If I have 6 minus 9 of something, I have negative 3 cookies or n's.
How did you get that? Did you just minus 6 from
Yep, so I just went 6 and then I subtracted 9. There's another like term here. It's our constant values. So this plus 9 and this minus 2 are on the same side of the equal sign, and they're called like terms, which means I can add them together. 9 minus 2 is plus 7. The other side of the equal sign doesn't have anything, so it stays as equals 37.
Isn't there an acronym for that?
We do talk about BEDMAS, which we'll get into, like
That's with brackets.
well, yeah. brackets, exponents, multiplication. We will do more of that tomorrow. Yeah. Cool. Now you've got a question just like the page before. But you had to collect like terms first to then be able to solve for it. So what number do I need to move to the other side first?
7.
Yeah, and the opposite of plus 7 is minus 7. So I'm going to subtract 7 from both sides. That gives me negative 3n equals 30.
Divide negative 3 and by 30.
Bingo. Now you got to get that negative 3 to the other side. That is timesing. The opposite of timesing is dividing. N equals negative 10. So we've added another step. Collect like terms, move addition subtractions, move multiplication. Let's try it again. So we got I over here. Our goal, oh, sorry, it was negative 10. When we look at I, the first thing we want to do is collect like terms. There are no like terms, right? So now we just get to start solving for x. What number do I have to move first?
6.
You have to move addition subtractions first. So this plus 6 has to go to the other side. You move it by doing opposite operations. So the opposite of adding 6 is subtracting 6. That leaves me with x divided by 3 equals 5. Then we have this thing.
9.
This means x divided by 3. The opposite of divide is?
Time.
Perfect. You're timesing both sides by 3. But if you can't recognize that's a division question, it's hard to know what you need to do, right? So you're multiplying both sides by 3 now. Because the opposite of divide is multiply. That gives me x equals 15.
So if you divide 15 by 3 and then add 6, it'll equal 11.
You got it. So checking your answers, you could take that value and it should work. So if you put 15 in here, divided by 3 and add 6, it should equal 11, which it does. Right? 15 divided by 3 is 5. 5 plus 6 is 11. Yeah. So you can actually check all your answers, see if they're right or wrong. For J, we got to move the 5 first. The opposite of minus 5 is adding 5, which leaves me with W over negative 4 equals 11. That is division. So that is W divided by -4. The opposite of divide is multiply by -4. So we multiply both sides by -4. That gives me W equals -44. Yeah, man. K. K is a little tricky because the order is out of normal for us. So the first thing you have to move here is this. And technically, that is a positive 14 being added to 3n divided by 5. So I need to move that positive 14 first. The opposite would be minusing 14.
Now it's 3.
That'll cancel out on the left, and I'll be left with 3n divided by 5 equals 30. And we get this weird like fraction spot. Yeah. So when you get this weird like fraction here.
How does 3n divided by 5 equal 3?
Yeah, right. We're going to have to move one thing at a time. So you're going to want to move. So when you get this situation, you move one thing at a time, right? I like to move division first. To me, that's the easier thing to move. So I'm going to move this 5 first. I do that by multiplying by 5. So I multiply both sides by 5. That gives me 3n equals 150. And then I move the 3 by dividing by 3. Which gives me n equals 50. So when you get those fractions, right, just move one thing at a time and just focus on that one thing moving. If you try to move the whole fraction, I find it gets messy.
Do you always do the denominator first?
And I always do the denominator first. Yeah, that's just, to me, easier. I don't know why. I just like to multiply before I divide. But it honestly doesn't matter. So you could have done that, and you could have divided first and then multiplied, and it would get the same answer. All right, L. L is a unique situation to us because I always say move the addition or subtraction first. But we actually can't on this one. The reason we can't move that -2 is because that -2 is part of that fraction. And so if it's on this fraction, it's like it's stuck up top until the fraction goes away. So what we have to do is we actually have to move the 3 first because the -2 is part of that fraction. So I have to multiply both sides by 3 to start this question, which is different than anything else we've done before. We had to get rid of the fraction so we could free up being able to move that 2. Now I can add my 2 to the other side. The order in which you do that is different, so that is one of the harder questions we'll see. Yes, sir.
Can I go to washroom?
You may. Go ahead and try all the ones beside it. They kind of match up with whatever's to the left of it. So try the next 5. I'll wander around and I'll help you out. They should match almost what's next to it. So if you look like P and L are kind of similar. O and K are kind of similar. So you can try them and look over. The trick with this first one, gentlemen, you guys can check your answers. So the trick with this first one is realizing that there's actually a 1 right there. So that's an invisible 1y. So you need to combine these two terms to become 5y. Right? That's 6y minus 1y combines to be 5y. Then this -18, -20 is -38. equals 92. That's the first thing I would have done, combine those like terms. And the y's are definitely the tricky part there. I then start solving. So I'm going to solve by moving the 38 first. And like we talked about over there, the order matters, right? You have to move the addition first. Every time I do something, you'll notice that I write it out and then I rewrite what I'm left with. So that is now 130. And then I move another number. In this case, I'm going to move the 5, so I divide both sides by 5. And I think, Reese, what did we get there? Was it 26?
H, yeah, 26.
Nail it. Perfect. This one. Again, moving the right thing first matters. This is a minus 12. I have to move the minus 12 first. Every time you do something, I'm doing the same thing. You move something, you rewrite what you have. So I move this 12 by adding 12. And then I rewrite what I have. So I have k divided by 5 on the left still. I have 8 on the right. So I did something, I rewrite it out. And then I move my next number. So the next number I need to move is that 5. I times both sides by 5 to get k equals 40, which I saw a lot of you guys had, which is good. Pardon?
No.
Oh, okay. And the first thing you have to move is that plus 6. You move that by subtracting 6 from both sides. That leaves me with negative 2x over 3 equals negative 32. So I moved something, I rewrote what I had. I then get this weird fraction situation. I like to move the bottom of the fraction first. So dividing by 3, the opposite of that would be multiplying by 3. Once I move that 3, I rewrite what I have. So on the left side, I'm left with negative 2x. On the right side, I have negative 96. Then I do something again. I'm going to divide both sides by negative 2. And I get x equals 48. And it would be positive 48 because those two negatives would cancel each other out. I know it's a little fuzzy on that screen. We're getting good at it. As these questions get bigger, something I will start to stress more and more is do something, so move something, and then rewrite. And then move something, and then rewrite. And then move something, and rewrite. And show your steps. It's way too hard to keep all those numbers in your head and be like, oh, I'm subtracting and multiplying and dividing. It's too hard. Show what you're doing. Write it out. For O, this is one of the harder ones. This is an invisible plus 6. So when I go to move that, I actually need to subtract 6 from both sides. That negative sign right here is actually attached to the n. It is not part of the 6. So I need to subtract 6 from both sides. That gives me negative n over 2 equals negative 24. That opening step is definitely one of the harder, trickier things we did in this whole worksheet. So you subtracted 6, and that negative goes to this n. You become negative n divided by 2. You then move the 2 by multiplying by 2. That gives me negative n equals negative 48. We had this situation, somebody did this with a different question. That negative is like an invisible negative 1. So that's like negative 1 times n. So you need to divide that negative 1 to the other side to get n equals 48. That is a hard one. All right, the last question. When you get these fractions, normally we would move the +8 over, but that +8 is stuck in the fraction, and anything that's stuck in the fraction cannot be moved until the fraction is taken apart. So this -2 on the bottom, I have to move that first. You move it by multiplying by -2. So I multiply both sides by -2. After I move something, I rewrite it out. So I'm left with 4a plus 8 equals -20. And then I can start to move the 8 because the fraction is now gone. So I subtract 8 from both sides. That gives me 4a equals -28. And then I divide both sides by 4, giving me a equals -7. Wonderful.